Hello everyone, so today we're going to be solving for angles and sides of right triangles. So the situations that we might be given a right triangle where they give us a side and they'll give us some angle, and we've got to solve some other side here or some other side here. Another situation that we might be seeing, so if we're given an angle here, a triangle here, another right triangle, and we're given two sides, we should be able to solve for some relative theta, some angle there. Okay, we'll be setting these up using our trig ratios that we learned and we practiced the last lesson. Okay, so let's look at this first scenario here. We've got this triangle, and we've got some angle theta here, and it's going to be at 30 degrees. We have our hypotenuse at 10, and we have a side x. So obviously we need to be solving for this side x. So the first thing we want to do is we want to identify the trig function here. Which trig function can we start at theta that has opposite and it has hypotenuse? So again, we have opposite and we have some hypotenuse. So I'd come to my ratio chart here and look opposite hypotenuse. We're going to be using sine theta. So we'll be able to set this up as sine theta equals opposite over hypotenuse. Okay, so we identified the trig function. So let's start substituting in what we know here. So we can say sine, well, what is theta? We know that theta is 30 degrees, equals my opposite over my hypotenuse being 10. Okay, so all we did was we substituted our theta in, which is 30, x is our opposite, and 10 was our hypotenuse. So we are done with that step there. And our final step says to isolate the unknown, where our unknown value in this case is this x. So on this side of the equation, we have x divided by 10. So we want to use reverse operations to get rid of that 10 there, simplify it out. So if I have x divided by 10, the opposite operation to move this 10 over would be to multiply both sides by 10. So this would simplify out. So you would say 10 sine 30 equals x, or if you want to flip it around, same thing, x equals 10 sine 30. So I know this is not the exact answer. Again, I want to make sure that these lessons are doable without the calculator. If you do have a calculator with trig functions and you're able to put in 10 times sine of 30, make sure that this is in degrees. But what I'm really focusing on is the actual skills to isolate those variables. How do we solve for that side? How do we solve for that angle? Okay, so this is how you'll submit your answers in today's activity, and this is how you'll submit answers on your exam as well. So you don't need exact values. I'm not interested in that. I want to know that you're able to identify how to solve for those. So let's try another one. All right, so we have this triangle here. Our theta here is 27 degrees. And we have some value of x here. We have some 5 up here on the hypotenuse. So let's go ahead and label our sides. Well, this side here is going to be our adjacent side. And the side up here is our hypotenuse. So I'm looking for something that says adjacent hypotenuse. So I come over here, oh, look at that. Cosine of theta is adjacent and hypotenuse. So we can identify our trig function as cosine theta equals adjacent over hypotenuse. Okay? So we've identified our trig function. Now, when we substitute what we know, we can say cosine of theta, and theta in this case being 27, is equal to, well, our adjacent would be x, and our hypotenuse is 5. So we're going to do the exact same steps that we did in the previous problem. We want to isolate our x. Okay, this is the guy that we want by himself. So to do that, we need to multiply both sides by 5. So we're going to have 5 cosine of 27 equals, well, these simplify out, equals x, or you could rewrite it as x equals 5 cosine of 27. And that is your answer for the side of that adjacent value. Okay? So let's do another one. This is going to be slightly different. So go ahead and identify our theta. We know that that guy is right here. We want to identify our trig function, so to do that we need to make sure that we identify our sides. So we know this is going to be our opposite side, and we have our adjacent side. So which one has opposite and adjacent as far as trig functions? Well, not opposite hypotenuse, not adjacent hypotenuse. Here we go, tangent is opposite and adjacent. So we can say tan theta is equal to opposite over adjacent. So we identified our trig function. Let's start substituting what we know. We can say tangent of theta, in this case theta is 15 degrees, equals opposite is 8 over our adjacent value, which is x. Okay, so we've got our substitution done. Now we want to start isolating our unknown. Now this is going to be a little different, as our unknown value, our x value, is in the denominator here. And so if we want to move this value outside this denominator, you guys already know we need to multiply both sides by x. What this does is x over x simplifies to 1, and we have an x value up here. So we can say x tangent of 15 is equal to 8. Okay? Now we still don't have x by himself because he's already tagged up here with this partner of tangent of 15. So to simplify him out, we want to divide both sides by tangent of 15. These simplify out. So we're left with x equals 8 over tan of 15. Okay, and that is your value. Our x is isolated. Just a little shortcut that I'm going to give you all. I'm not a huge fan of teaching it like this, but I know some of y'all will see this, and I want to make sure that you guys get it. So let's talk about a little shortcut here. When we saw this question, or this equation of tan 15 equals 8 over x, a little shortcut that's you guys will start catching on to is when you want to isolate this x, a lot of you guys are just going to see, well, look, I'll just take that value up here. I'm going to switch them with this value here. Okay, what I mean by switching is you just exactly write them in those respective spots. You would say x equals 8 divided by tan of 15. Now this works only when that x value or that unknown value is in the denominator. You can just switch those values there and you'll get your answer. But conceptually, you want to go and understand the steps. Okay? Let's do another one. So let's identify our trig function. So let's label our theta. Okay. So theta's there. Okay. We've got our opposite side. And we have our hypotenuse. Okay. So opposite and hypotenuse. What do we have here? Well, opposite hypotenuse is going to be sine. So we'll say sine theta is equal to opposite over hypotenuse. So let's start filling in what we know now that we've identified our trig function. Well, sine theta, well look here, I'm actually going to be solving for theta. Theta is what we don't know, okay? So we're going to write that as sine theta. Our opposite value in this case would be 3 divided by our hypotenuse, 5. So we're just looking for that theta value. Okay, so if I'm looking for this theta value, I need to get rid of sine. So I need to reverse operate sine. Well, how do we get rid of sine? Well, you guys know that if we have to get rid of an x, we do x over x, right? So if I want to get rid of an x, we do x, divide that by x, and that gives us a nice 1 here. So in other words, I want to simplify this sine to give us a 1. Well, we've learned from laws of exponents that if we take some kind of x value and we set it to the power of 0, anything to the power of 0 is equal to 1. So we want to apply that same concept with sine. So what we're going to be doing is we're going to be taking the sine inverse of each. So I'm going to write that up here. We're going to say sine to the negative 1 is sine inverse, okay, or the inverse sine. Now, the way this works is when we take sine to the negative 1 and sine, well, sine has an exponential value of 1. When we're multiplying these, we have this rule of exponent where we're going to say sine. Well, remember, we add these values here, negative 1 plus 1 is sine 0, and anything to the 0 power gives us 1. So what's happening here on this problem is this sine to the negative 1 and sine are simplifying out and giving us 1. So what we're left with is just theta equals sine inverse of 3 over 5. You want to put these in parentheses as that belongs there. Okay? So I've explained to you how inverses work, like sine inverse. We'll discuss cosine inverse and tangent inverse as well. I want you guys to understand like why it works, not just like, oh, just put it to the sine of negative 1. No, I want you guys to really understand the process for that. That's why we did this down here. And we've got our unknown isolated. So we'll do some more practice problems on this. I know inverse trig functions is something new for us. And you're going to be using a lot of this next year in pre-cal. So we'll make sure that we get you some good practice coming in right now. So let's do another one. So let's go ahead and identify our trig function. So we know that we're going to be solving for some theta. We're given some adjacent value. And we have a hypotenuse. So let's go ahead and identify our trig function. We're looking for adjacent and hypotenuse. Well, look, check it out. That's going to be cosine. So what we're going to do is we're going to say cosine theta is equal to adjacent over hypotenuse. So we've already identified our trig function. Let's go ahead and substitute what is known. So we know that cosine theta is what we're solving for. We're solving for that theta. This is equal to our adjacent value is 6 over our hypotenuse value, which is 7. So in the last problem, to undo a sine value, we use inverse sine. So what would you use for cosine? I don't know if some of you guys are saying it. You would use cosine inverse. So you would say cosine to the negative 1 of both sides. Remember, what you do to one side, you do to the other side. But what happens with cosine inverse and cosine? Well, we simplify those out. And so we're left with theta equals cosine inverse of 6 over 7. And that's your answer there. Okay. Again, I don't want exact answers. You don't need to be doing this in a calculator. I want to see the work values. Okay, let's do another one together. So you'll see this is a similar problem. We want to go ahead and identify the trig function. So we're looking for some theta. We're given an opposite, and we're given some type of adjacent. So let's go ahead and identify the function, or the trig ratio actually. So opposite and adjacent, oh look, that's tangent right there. Okay, so we'll say tangent theta is equal to opposite over adjacent. So let's start substituting what we know. So we can say tangent, and we're looking for theta, is equal to opposite being 3 over adjacent being 4. So if to undo or to simplify out a sine, we use sine inverse. For cosine, we use cosine inverse. For tangent, we would use tangent inverse. These simplify out, we're left with theta equals tangent inverse of 3 over 4. So just like the last two problems. Okay, I hope this is getting a little easier for you all. The process is pretty much the same. Okay. Got a few more problems. Oh, look at this triangle here. Okay, I love these types of problems as it's the exact same thing we've been doing, except you kind of have to just change your mindset about like where these sides are. So let's do this problem together. We're going to go through the same steps, nothing changes. Let's identify our trig functions. Oh look, here's our theta value. He's like a little different there. We need to identify our trig function, so we want to make sure that we identify what is given to us. Well, this x value is what? If we look in relationship to this theta, our starting point, this guy would be opposite, okay? And this long side here, which is opposite of the 90-degree angle, would still be our hypotenuse, okay? I know some people like to redraw it, like they can see like, oh, I'm going to do this here, then I can label this 30, and I see like, oh, look, it's opposite of that, so that's going to be my x, my hypotenuse is 5. You can do that, but it's also important to be able to start visualizing these problems in different rotations. And I think if you need to draw it, that's fine for now, but I want you to start getting some practice in visualizing the way it is just as. Some of y'all might become engineers. This is going to be huge when you start taking statics and dynamics. You'll get a lot of problems set up with triangles in different ways, and so it's a good way to start visualizing. So we've identified our sides, so let's start setting up our trig function where we have opposite and hypotenuse, which is going to be sine. So we'll say sine theta is equal to opposite over hypotenuse. So now let's start substituting what we know. Well, we know sine theta, in this case theta is 30, right? It tells us right here, is equal to opposite, which is x, over my hypotenuse, which is 5. So I've identified the function, I substitute what I know, and I need to isolate. Well, I need to isolate just x. To get x just by himself on one side, we need to multiply both sides by 5. This is nothing new. These simplify out to 1. So we get 5 sine 30 is equal to x. Or in other words, x is equal to 5 sine 30. So same thing we learned at the beginning of this video, except we just had a different rotation on the triangle. It's just good practice to see that. Let's do one more together. Look, it's a triangle and he's all flipped around. So again, we go through the same steps. Nothing changes here. So we're going to identify our theta. Well, in this case, theta is not given, so theta is theta. No worries. And our sides here, well, in relativeness to this theta, this 6 would be our adjacent. And this long value here of 8 would be our hypotenuse. Again, he's always opposite of the 90-degree angles or hypotenuse. So let's identify the trig function. So we've got adjacent and hypotenuse. I come over here, oh look, check it out. Adjacent and hypotenuse is cosine. So what we're going to say here is we're going to say cosine theta is equal to adjacent over hypotenuse. All right. Okay. So with cosine theta being equal to adjacent over hypotenuse, we start filling in what we know. So we know cosine theta is what we're going to be solving for, is equal to adjacent, in this case would be 6, over our hypotenuse, which is 8. Okay, so we've got 6 over 8, and now we're going to be isolating our unknown. Okay, so if we want to get theta by itself, we need to simplify out this cosine. What simplifies the cosine? Now you guys are thinking it, you're going to say cosine inverse of both sides. So these simplify out, you're left with theta equals cosine inverse of 6 over 8. Now you can reduce that 6 over 8 to 3 over 4, but if you were to put this into the calculator, you would get the same answer regardless, so I don't want you worrying too much about that simplifying, but you could also say cosine inverse of 3 over 4. So we've just done actually 8 problems solving for angles and sides of right triangles given special parameters. You notice that every single one of these problems use the exact same 3 steps. Those 3 steps being to identify the trig function, substitute what is known, and isolate the unknown. Okay, we really could have put simplifying there at the end as well, but we'll take one step at a time. So please don't forget to complete your assignment for this lesson. If you have any questions, hop on my video hours or during one of my conference calls and we can definitely discuss questions like this. Okay, there's also another video similar to my video in your classroom notebook, so please check out that video too if you'd like to see this explained in a different way. I hope this made sense to you all, and we'll see you all later.